All right, so here we are on lesson 13 of our tile game tutorial. What I want you to do is to go to sprites, please. And I've got on my view, I have my program outline up. And you can see that we have 3 classes and 2 functions. Now, they call them M for method. Technically, I would call them functions because they're outside of the class. But just remember, method and function are basically synonyms. So these, if I expand my class, you can see the different methods that are inside it, or functions that are inside it. So if they're outside of a class, then I use it for anything. If it's inside of a class, you have to use it on that player. Okay. Well, let's go to make a new class, and I'll make it. I think I'll make it right up below zombie because it's a sprite. It's not as pointless as the wall. Our wall just sits there, but it is going to be not used all that much. Like, we won't be making a lot of edits to it, but we're probably going to go back and make some edits to zombie. So we'll leave zombie as the second thing, okay? So let's go ahead and make our class for a bullet. And our bullet will be a sprite. And so remember, when you put in a class inside parentheses in Python, when you make a class, you are inheriting all that code. It's like copying and pasting the entire sprite class, all that code, without worrying about making a typo or something. You get all that for free. So it's a really nice way. And the Pygame sprite class is a nice class, so we like to use it. All right, let's do our init. And I need a reference to the game, as we've done each time. I'd like a starting position and a starting angle, because our bullet is going to be launched at a location, and it will be launched with a direction. Anytime we subclass, we need to call the super constructor in the super class. We need to call the init in the super class of sprite. Okay, so let's keep a reference to our game. So we're going to make a game property that we can use. We've done that a lot. I'm going to go ahead and add this to my sprite group in the game. So remember, our game has a sprite group, and we use that for calling the update method of each sprite, and we use it to draw each sprite. Very important. And I could say self.game, that's right, but it doesn't matter since I have a game variable here, but I guess I'll be consistent. And self.game. Well, we're going to have a new group in our class, our application. We're going to add a bullet group. And we'll add ourselves to that. So before we forget or go any further, this group does not exist yet. Let's go make it. So let's hop over to main, which is our application, and let's go ahead and add that in. So right under here where I have wall group, let's make a group for bullets. So this will be a group for all my bullet sprites in the game. Self.bullet group. Pygame.sprite.group. So we're making a group that, remember, a group is kind of like a list, but it's got a little more functionality than that. It allows us to check for collisions with just certain things. And specifically, I'm going to want to check for collisions between my zombies and my bullets. And that's going to handle all that for us. So that's a nice win for us. All right. So now that bullet group exists, I'm back in sprites where we left off. That bullet group has now been made, so we can add to it. But we have to get to it through game, of course. All right. We need an image. And we're storing all images in our game. So self.game.bullet image is where we're going to get that. But guess what? That doesn't exist yet, does it? So, and we could just draw a circle here if we wanted, really. But we're going to load all our images in our main. So let's hop over to main. And you'll notice we have a load image function in main right there. So that's where we need to do this. So we're going to call this, I'm just going to space this a little bit. I've got player, and then I've got zombie. This is going to be bullet image. So I need to join my images directory with bullet image from settings. And I don't have a bullet image in settings yet, but we'll add that in just a second. So whatever my bullet image is, that's what it'll be. And then we'll say self.bulletimage, pygame.image.load, my bullet image file. And don't forget convert alpha when you load an image, which will keep the transparency and make it fit in the pixel outline of my screen. If you don't do .convert, you can have some real problems with your images. They may not line up pixel-wise. I'd also like to use a setting to scale the size of our bullet. Because as our game tile sizes get bigger or smaller, that might be an issue. I don't want to be shooting a cannonball. So let's go ahead and transform this. So that's pygame.transform.scale. And the scale function takes an image. That's my bullet image. And a tuple for the size. And we'll just do bullet size by bullet size. I don't know if you can see all that. Let me zoom out just a little bit. So remember the pygame function for scaling. So enlarging or shrinking an image is in the transform submodule. And it takes in two parameters. First parameter is the image you want to scale. The second parameter is, it looks like two parameters, but it's a tuple in parentheses for the length and width that we want. And we want it to be a length and width of bullet size. And it returns a new image. It doesn't change this image. It creates a new one with that size. So that's why I have to save it back in itself. Okay? All right, well, we just referenced several things in settings that don't exist. We referenced a bullet image, and we referenced a bullet size. So let's go to settings. And here's our image files. We need to add that image. This was called bullet image. And I've got one here that I'll share called circle bullet. All right, so I've got circlebullet.png. You can see a little thumbnail of it here in my images directory. So that's good. We have a couple more things we need to add to our settings because we need to make a bullet settings area. So I'll call this here bullet settings. And I want bullet speed. We're going to make several of them while we're here. 500. Bullet life. 1,000. Fire rate is 200. and bullet size is 10. We haven't used bullet life or fire rate yet, but we will. So let's go ahead and make them. And you can play with these settings to see what they do for the bullet. I have a bullet life because I don't want it to like go forever across the screen. I want it to have like a range before we could say it fell to the ground. All right. Okay. So I'm going to go to, let's go back. Finally, we get to hop back to sprites. And we have an image now. Let's get a rect for positioning. That's our favorite method. Call image.getRect. Any surface has a rectangle associated with it. We get to use it to position. Self.rect.center. We're going to use the center of it at our position. Let me zoom in just a little bit here. So, again, all I did was create a rect, which is a rectangle using getRect, and I set its center at the position that will be sent, which will be a vector. Let's make a position vector for ourselves. Now, this is actually pretty important. If you don't create, now position will be a vector that we're going to send it. But we want to take that vector and create a new one from it, or else this bullet's going to move around the screen based on wherever the vector is that you sent it. I don't want to go too far into this idea of reference variables, but we're going to be sending a position, and that position we send it is our current location. And if I move, that current location will change, which would cause my bullet to change. So I need to get its own way. So the vector2 class has a constructor that takes in another vector for this very purpose. So it takes in a vector and creates another vector that's exactly like it, but will be a different vector, just happening in the same location. Okay, next what we're going to do is we're going to make another property for our velocity. Our velocity will also be a vector. And we're going to do something that we've done before. We're going to make our vector simply point to the right along the x-axis with a length of bullet speed. So it's pointed directly to the right, and then after we create it, we'll rotate it towards the angle that we were given. Oh, I haven't made my angle yet. So that's a mistake. Sorry. Right under self.rect position, let's do that here. Self.angle is equal to the angle they gave me. There we go. I want to keep a reference to that. So we have an angle, we have a position, we have a velocity. One last property I'd like to keep. Self.spawn time. And we're going to say pygame.time.getTick. Turn the clock, the number of ticks of the clock. It doesn't matter. Just think of that as a time. And we want that time when we created it so we know how long it'll be. Place. All right, so I think we've got everything we need. We just need to write, before we test it, we just need to write the update method, and then we can fire some bullets. So our update, which is called every frame, we're just going to move our position by our velocity times the number of milliseconds since the last frame, which is stored in the game.delta time. So I move my position, and then I'll go ahead and move my rectangle to that place. And for now, let's just remove the bullet after it's been gone for too long. Later we'll add if it's interacted with something, we'll also remove it. So if pygame.time.get ticks, so that's the time right now. If the time right now minus the spawn time is greater than our bullet life, remember we made a bullet life setting in milliseconds. So I think we left it at like, we left it at 1,000. So our bullet's only going to have 1,000 milliseconds or 1 second of life. After a second, we're going to say that bullet's done. Then we just say self.kill. That's a method in the sprite that we inherited from Sprite that just removes it from all the groups so it doesn't get updated or animated anymore. All right, y'all ready to fire this bullet? All right, well, we can't really seem to reach an agreement here about whether we want to do a mouse click to fire or a spacebar, but let's try it. So if you would go to your, we're going to go back to our player class, and it's going to be in check keys that we'll do this. So currently we have up and down or W and S to control our moving forward and backwards. And then in our update, we get the position of the mouse and we use that to position where we are. Well, we can also get the mouse click status. So let's do that. We got a keys. Let's do I'll call it buttons. Buttons equals pygame. This is very similar to the keys. It's pygame.mouse.getPressed. You'll notice it's almost exactly the same. It's going to be a list of true and false, okay? And the first element in the list is button 1, then button 2, and then button 3. I don't know if they have like a special thing for it or if you're just supposed to use indices. All right, so if buttons bracket 0, so that should be the left mouse click. But maybe they want to use the right mouse click. I don't know. So you could do an or. You could also do a keys space. So I'll let you decide if you want that. But if they press the left mouse button is what I'm going to go with now. Then we're going to create a bullet. But actually, before we do that, I want to make one more. I want to make one more method. I don't want them to be able to just rapidly fire super fast. So I'd like to make one more property in the. I'd like to make one more property in our person player class right quick. So right here at the bottom of player class, would you add, please, self.lastFireTime? And we'll just say 0, okay? So we're going to, that's in the init. That's in the init of player, okay? Self.lastFireTime. So I'm going to use that here because I want to make sure it's been enough time. So yeah, self.lastFireTime. Just say equals 0 because when the program starts, we'll say it's time 0. So if button 0, let's get the current time. Current time is the get clicks. So this get ticks. This just tells you how many milliseconds the game has been running. And that allows me to say if current time minus self.lastFireTime is greater than fire rate. So my fire rate's not so much a rate of fire as much as a rate of delay. So when we said that our fire rate was 200, we meant, which we said here, we mean 200 milliseconds between each fire as a minimum. Well, that's saying if it's been long enough, Then we're going to say self.last fire time is the current time. And we'll create a bullet. And it's not going to be perfect because we need to add an offset, but we'll worry about that later. For now, we'll just run that and see if we can't get it to work. So as it currently stands, we have a game where we can fire, but you see the bullets come out of like my chest. They don't really come out of the player's gun, right? And that's because we're sending it from our player location. So that's the first of several things we're going to fix. So what we need to do is go to where our bullet is being created, which is in the player class in check keys. So you can see that we have a bullet created at self.position. But we need to adjust that some so that it is moved in the correct angle. And the amount you need to move from one place to another is a classic vector. So we're just going to create one in settings called gun barrel offset. Okay? And if we have different guns, different sizes, we might have to adjust where this value, but that's fine. So we're going to take the vector and we're simply going to rotate it by the angle of the player. So no matter which way the player is rotated, the gun barrel offset will be rotated with that. And then we'll just simply go over to our settings. And we're actually going to add a vector to our settings. So let's pop over to settings. And we'll go down to our gun settings. We already have one vector already. So down here at our bullet settings, I think. No, let's do it under player settings. We'll make a vector right here called gun barrel offset. And we could play around with this and find what is the correct vector to use. But I found 2810 to be the right one, I think. I think that's right. I may have to change it, but we're going to try that. So which means move 28 pixels to the right, because my gun is in my player's right hand. And then we're going to move 10 pixels forward, because the gun's a little bit forward. Okay? And there we go. So that's what we're going to do. I'm also going to, I think I'm going to shrink the size of my bullets just a little bit. See if I can't make that a little bit better. I think it's too big. So I'm going to make it 6. See what that does. I also don't like that it's kind of hollow, but. All right, so we'll pop back over to sprites. And remember, the only change we've done right now is that we just added the gun barrel offset, rotated to be in line with our player angle. And we'll run main to see what effect that has. All right, so if we run it, we should see a good setup here. I like the way it's coming out of the end of the gun barrel, I think fairly accurately. So we're going to stick with that. Okay? Okay, it's time to make these bullets do something. So let's pop over to main. And let me show my outline here so I can easily hop around. So in our main.py class application, I want to go to game update. So our game update method is the method that is called, that we call every frame. And the first thing we do is we update all of our sprites in our sprite group. We then update the camera. Now it's time to handle some events. Just going to comment or two here. So this is me update the camera position. And this is me updating the sprite positions. But we're not really updating the logic of the game. So let's do that. I'll call this handle bullet collisions. So we'll make a list called zombie hits using pygame.sprite.group collide. So we've already seen sprite collide, which takes in a sprite and a group of sprites to see if there's any collision. Now we're going to look for collisions between two groups. The format for group collide is first give it a group that you want to know about collisions from. So I'll do self.zombie group. Then I want to know what it's colliding with, what element, so it's going to be the bullet group. And then we have to answer two questions. When we did sprite collide, we had to say, do you want to kill the sprite? Do I want to kill the sprite? Actually, I do not want to kill the zombie. Even though we're just going to kill the zombie right now, in a later lesson, I want us to actually give health to the zombies, so you have to hit them more than once. So we'll go ahead and make that false. Don't kill the zombie. That's what the first false is for. True, kill the bullet. So the bullet will be removed. And the zombie hits, this value is a list of all the members of this group, this first group, that hit the second group. So the zombie hits list will be a list of zombie sprites, not bullet sprites. We're going to iterate through that list. So we can get a list of the sprites by saying, calling a list method, but we'll just say for hit in zombie hits. Oh, it already is a list. Sorry. Forgot about that. And for now, we'll just go ahead and kill them. So each element, each hit in zombie hits is a sprite. I don't like the word zombie hit. I'm going to call it zombie. So in each zombie in the zombie hits list, this is a list of all the zombies that got hit by a bullet. Zombie will be each one at a time. The chances of us hitting more than one zombie in a frame are pretty rare, but it could happen. It would kill both of them. So let's give it a try. And you can see that we're able to take out a couple zombies. And yeah, we're pretty awesome. And now I can start really populating this place with some more zombies and killing them. Okay, I'm pretty happy with this. We're just going to make a couple more changes. We're going to add a little bit of kickback from our gun. And we're also going to add a little randomness. So let's go to Sprites module. And we've already imported Pygame and Math. Let's import from random. I'm going to say from random, import what's called uniform. So uniform is a function in the random module that gives a real number, so it could be decimals, from A to B. So if I say, give me a random number from 0 to 10, the uniform function could give me 1.7, 3.8, 4.0, any of those numbers, as opposed to the rand int function that just gives me integers. And I'll use this to navigate. I'm going to go to my check keys method. And when I fire a gun, I'm going to get a spread, which will be from the uniform distribution of negative. Let's make a setting called bullet spread. So it's going to go from negative bullet spread to positive bullet spread. And we'll, of course, need to add that to our settings. So we'll say bullet spread. And, you can play around with this value. We'll just start it at 5. Okay? So that's what we're doing, is adding a spread there. So how do we use it? Well, currently we are firing our bullet. We're firing, remember, our bullet takes a reference to the game. We need that. It takes our position with our offset. But the third property that we create it with is the angle. Well, I'm going to just add the word spread to that angle. So on average, our bullet's going to fire directly in the direction we're facing. But sometimes it'll actually be angled a little left and a little right. All right, next we're going to take and add a kickback, which is going to affect our bullet, our personal velocity. So we'll say self.velocity equals pygame.math.vector2. And this is our bullet kickback. And it's going to be directly backwards, so we're going to rotate it by our angle. So we're going to make a vector that faces in a direction we're facing, but actually moves backwards. And I know that it's been a while since we talked about that. Let me make sure that we're up to speed on how exactly this works. So we're creating, usually when we make these vectors, we create the vector to go along the x-axis for the length we want, and then simply rotate it to the direction we want. Well, what we're going to do this time is we're actually going to make the vector backwards. So if you can imagine me rotating to the direction that I'm facing, this is the way we're facing, and we're going to make the vector go negative, so it pushes us backwards in the opposite direction of the gun. We just need to add a bullet kickback value to our settings, put it in your you can put it in your player settings or your bullet settings, whichever you want. And I used 50. So I'll just put that here. Bullet kickback equal to 50. Okay? So just looking at the effect, you can see that my player is moving back. I would feel like you might want a little bit more kickback here. But if we add a shotgun, that would fire multiple projectiles at once, that would have a bigger kickback. But notice the spread. It's averaging nicely, but it's just not exactly the way I expect. That gives a more realistic image, though. Okay, so I'm going to call that a good stopping place.